Okay, sir. So I'm pleased to welcome Dr. Rishabh Kaushal, who is here today to share his knowledge on LLMs and their impact on healthcare. Dr. Rishabh Kaushal is currently working as a postdoc researcher at the Institute of Data Science in the Department of Advanced Computer Science at Maastricht University, Netherlands. He is on a study leave from Indira Gandhi Delhi Technical University for Women, Delhi, where he has been working as assistant professor in the Department of Information Technology. He completed his PhD from IIIT Delhi and his master's from IIIT Hyderabad. He has more than 10 years of teaching experience. His teaching approach is learning by doing, which means an emphasis of on practical problems to understand concept of theory. For research, he applies concepts from machine learning, artificial intelligence, graph algorithm, and data science into the applied field of social media analysis, solving problems related to content moderation, hate speech, misinformation, and fake news. Over to you, sir.
Yes, hello everyone. Thank you for the introduction and let me share my screen. Then we can. Okay, I hope you can see my screen and you can hear me clearly.
Yes, sir.
Yes, 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 Kaushal. Richa, have you started
Okay.
recording?
Yes, ma'am, it is started.
Okay, okay.
Okay, so this talk is going to be uh, a very gentle introduction on large language models and what are the different ways in which people are using large language models in the domain of healthcare, and particularly when they say healthcare and AI. So large language models are becoming very, very popular. Some of you, I'm sure, would be already using them in your research domains, and maybe some of this content might be repetitive to those who have already been working in this domain, and for some of you, it might also be new and it might open up new ideas where you can apply this in your own respective domains, not necessarily in health AI. So I've tried to put this talk in the context of the overall theme of the FDP, which is related to healthcare. But nevertheless, it this can also be a takeaway, can also be that you can use these large language models and try to look at the problems you are working on in any domain. So as already introduced, I'm on a study leave from Indira Gandhi Delhi Technical University for Women. I'm doing postdoc at Maastricht University, and uh, yeah, and last few days I've been traveling, so there has been a change in the schedule. So I did my PhD from IIIT Delhi, my master's from IIIT Hyderabad, and undergrad from IP University. So I would put this talk in two large context. The first is I would give an overview of what LLMs are, a bit of background for those who don't know what LLMs are about. And in the second part, I will look into the healthcare applications, how people are applying LLMs in solving problems in healthcare. So let's get started with large language models. But before we go to large language models, we will look at what a language model is after all. So a language model gives us a probability distribution over a sequence of tokens. In a very, very simple way, this is how we can define a language model, which basically means that, let's say, if there is a sentence, the monsoon rains have arrived, and there is another sentence, monsoon the have rains arrived. So the large language model should give us a probability, what how probable is a particular sentence. So the first sentence, the monsoon rains have arrived, this is highly probable. It's a sentence, it's a grammatically correct sentence. It one can imagine that it in a very large uh, set of sentences, or in common knowledge, one would often read a sentence like this. So a language model should give this with a relatively reasonably high probability. So this is reasonably high probability, though it doesn't look like to be. But as you compare it with another sentence, monsoon the have rains arrived. So here the sentence is not grammatically correct, and it is very unlikely that these words will be used. Words, or in other words, tokens. So tokens or words are used interchangeably. It is very less likelihood that these tokens will come in this sequence. So the probability is 0.001. And this is what a language model gives. It gives you a probability distribution over a sequence of tokens. And tokens, a set of all possible tokens, is referred as vocabulary. So in this particular example, our vocabulary size is very, very, very small. And it is just having these set of 7 words. But in a real world setting, or with language models which are commonly used, the vocabulary size will be very large, so that it can capture almost any possible sentence that we can think of in a language. What LLMs, what LMs can generate, what they can do is they can generate text. So traditionally, they have been used to solve this problem of next word prediction. So given a set of words, given that the words the monsoon rains have, given these sentence set of tokens or these words, the language model can compute what is the most likely token which would come next. So for generation, the next token is sampled from a probability distribution of its vocabulary. So right now the vocabulary is very small, and from this small vocabulary, it turns out that the word arrived has the highest probability to come. So given these set of tokens, the probability of the next token out of this being our vocabulary, is zero point 0.4, and therefore it is given as it is given, it is generated as the next word. So these language models are generative models. They can generate content. And this is the foundation, or this is the founding principle on which they do it. And how they do it, if given this vocabulary and given a set of large sentences that they already know, they compute the likelihood, the probability of these set of tokens in a sequence. And using chain rule, this can be translated as probability of X multiplied by probability of the next token, which is x2, given that x1 has already arrived or is already known. And then what is the probability of x3 given that x1 and x2 is has already have already appeared, and so on. And then it can be notationally it can be put in this notation. So this is what basically the language models can do. And what is large about these language models and so based on this principle, uh, people have proposed models with a very large set of tokens as the vocabulary. For instance, if you see over here, I hope you can read this, at least the right graph. The x-axis is the token, and there are large number of tokens. On the y-axis are the names of the models, some common large language models. And you can see the corpus size has increased. The number of unique tokens, the vocabulary size has increased. So it's like 10 raised to power 9 to 10 raised to power 12. So the GPT-3 is 10 raised to power 12. And the number of parameters on the left, if you see the number of parameters in a model that the model needs to learn, have also increased from, I think you may not be able to read this, from 94 million to 280, 280 billion parameters. So these are the different kind of parameters that these models have to learn. And this is how these large language models have evolved, and we don't have to get into a lot of details about it, given that our focus is on their applications in health AI. So, but this was one of the founding papers which everybody speaks about. Attention is all you need, and transformers were introduced by Google, and then they, based on the transformer architecture, they then proposed another very popular model of BERT, and a lot of models are yeah, okay. Uh, then GPT came, and it is now we know Chat GPT is very popular and a lot of us are using it. Uh, but it was introduced, the first version of it was introduced by OpenAI in 2018, and then GPT-2 in 2019, GPT-3 in 2020. In between, other big tech like Meta, they also introduced another popular model, Roberta. And then this was a major milestone or a landmark in this very recent history of LLMs. On November 30th, almost 2 years back, more than 2 years back now, OpenAI launched ChatGPT. So ChatGPT arrives, and a lot of us are using ChatGPT, right? Uh, Students are using ChatGPT to solve their assignments, and I'm quite sure, I mean, teachers are also using it to prepare assignments. And we both are learning, and in this learning journey, we both are using ChatGPT. But important part is we need to verify this because ChatGPT could hallucinate, and we will talk about that aspects sometime later. So, uh, uh, until now, we explained the LLMs using a text example, but it does not mean that it is only based on text data. So there are now multimodal LLMs with multiple modalities. So you also can have sound, you can have video, you can have images in addition to the text, and there could be different input modalities, and then you encode these modalities in the embedding space eventually, and then you are passing these embedding vectors along with the input vectors, which input text, which is tokenized and which is anyway was being fed to the LLM uh, in before. So in essence, it means that LLMs can n- not just read a lot of input text as a training data, but they are also given a lot of images and multimodal data also as input. And in turn, what LLMs can do, they can not just generate a text, they are not just predicting the next word, but they can also predict, and they can also generate images. Like they can predict the next pixels, and they can keep generating the images, and also the videos. They can predict the next scene or the next sequence in a particular uh, frame or video frames or sound. And so that's the idea. That's where the LLMs are. So this sums up the first part of the talk, and now we go to the next part, the most important part, which is the impact of these LLMs in the health domain. Before we look into the impact, we will very quickly we will look into what are the challenges in healthcare. And in the real world, these are some of the challenges. There are lack of clinicians, lack of doctors. It may not be an issue in India. There are a lot of doctors. Healthcare is very easily accessible, though it is costly, but it is accessible. Private healthcare is there, and public healthcare is also there. But in many other countries, and in many what we call as developed countries, the healthcare, this is a crisis. I mean, they don't have too many expert doctors. So it is a problem, a real problem, that if you have to get yourself operated, you have to wait for few weeks, sometimes few months, if it is not life critical and not very emergent operation to be performed. uh, you will not get the appointment for getting the operation done or the treatment done. So this is a real problem in the world. In India, we may not appreciate this, but the world has this problem. It's a major, big problem. Uh, then there is another trend which we are seeing is with the advancement of healthcare, and the new facilities, the life expectancy is increasing, which also means that more and more of your population is going to live longer, and they are going to remain old. And people in their old age, they need medical assistance. It may not be all of the medical assistance need not be like an emergency or an operation, but they may need day-to-day medicines, day-to-day advice about their problems. And so if imagine, I mean, if people were the average age were to be like 60 years, then people are dying very soon. So you don't need a lot of healthcare assistance. But now, because the life expectancy is increasing, you need more uh, of the healthcare. So And then on the right is explaining these problems. So general knowledge providers, and there are patients, and application of general knowledge, too time consuming to find and apply knowledge. Even these days, like we try to find out remedies. If something happens to us, we try to find out like I don't know. I mean, what is our immediate reaction? Do we go immediately to a doctor? Maybe no. I mean, I don't do that any longer. I mean, if I'm not feeling well, I will first try to search it online and see what's happening, right? So we are in a world with where knowledge is available on the web, and we try to find a solution to small issues that could affect us. So but do we get the answers? That's the question. If I'm not feeling well, if I'm sick, or if my lower back is paining, let's say, what is it? I try to find out some exercises, or I try to find out some treatment, or Ayurvedic treatment, for instance, or allopathic, or whatever. It is time consuming to find the correct knowledge. We don't know how reliable that knowledge is. So, and how do you connect the those who have the knowledge and with people who are seeking that knowledge? So that's one problem. The second problem is communication. The doctors, particularly, you might be, even in India, the doctors are, they are one profession who speak very less, and they will very quickly attend to you, and then they will say, okay, we are moving next to the next one. So there is lack of time. There's no time. Documentation, coordination, lot of documents, history, medical history needs to be seen and needs to be recorded and seen. And these are some of the challenges in the healthcare domain. What LLMs do, what LLMs bring to the table. So these couple of things I have taken from an online blog. I will share the link uh, to you. Uh, is how LLMs can do. LLMs have this ability to read very large amount of text. So if you already have large amount of medical related books which could prescribe, which does the prescription, which does stuff like that, and you can retrieve knowledge, and you can query this LLM which has read medical related corpus and medical related information, and then you can question and it will generate the answers. It can also be positioned, LLMs can also be positioned as a chat solution. So there could be a conversational AI or a chat which you can you can talk to and then seek answers to your everyday or casual queries about some ailments that you get. Then about the documentation. So we all know, I mean, so the IT and AI, you can keep storing the data, and then retrieval of the data can be done through AI, and you can apply information retrieval techniques, and LLMs can play a major role in that. So with that, I now go to the major applications, or where LLMs are being used or can be used. And there are, like, broadly, we can think of this in two ways. One is LLM for patients and LLM for doctors. As I said in the earlier discussion in the background, for the teaching learning process, both the teachers as well as the students, both are learners, and because learning is lifelong, both are using LLMs to solve their problems. In the same way, patients and doctors both can use LLMs uh, to to help them. For instance, doctors can use LLMs to assist them, for doing the medical diagnosis. And it it may not be it may not be the case that they are completely relying on LLMs, but it could be that they want a second opinion, or they want a reassurance of their diagnosis, and they can use LLM for that. Medical literature analysis. So, like even in the field of medicine, the treatments keep evolving, and we all have gone through the COVID period, and we know that we were clueless at the beginning, and we were doing one set of treatment, and then few months later, then experts said, no, 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 that treatment doesn't work, and then we have to do another set of treatment, and all sorts of things were happening. So analysis of literature, how things have evolved, how treatments have been done in the past, is also an important subject. In fact, to study MBBS, it takes more time. So you need to do a lot of literature analysis. Then clinical decision support. So this is again when you have to uh, take a decision, like what is the kind of treatment that I have to do. You can make use of LLMs. So treatment planning, collaborative diagnosis, and explaining it to the patient. What are the pros and cons? So it is always good to keep make things a bit more transparent. Uh, that's where I believe healthcare with AI is heading. Then, from the point of view of patients, health education and lifestyle advices, like I said, so we all most of us are doing sitting work, and we sit for long hours, and we have these common lifestyle problems, or we are uh, spending a lot of time on screen, and therefore our neck posture and is not correct. So we keep seeking these advices for these issues. Sometimes our neck is paining, or sometimes the lower back is paining, or things like that. So LLMs can help. Virtual medical assistants, healthcare chatbots, patient care. These are again areas in which healthcare LLMs can be put to use. And one of the things which I would, so this diagram is taken from this paper. It's a survey paper. So I will. There is a also in the references there is a link to it, and this is the paper that I have referred to. So I will. Uh, I will anyway. I will share it. Yeah. Okay, so let's look at each of these segments. Like, let's see what are the different applications. Clinical language understanding. So LLMs can potentially, they can amplify the efficiency and effectiveness of diverse healthcare applications. And some of these tasks which uh, involves named entity recognition, in the medical context. So, named entity recognition, those who are familiar with natural language processing would know that this is like names of locations, names of persons. So, in the context of medical, it would be names of diseases, names of medicines, or names of the kind of treatment that needs to be done, and the relation extraction. So, for example, relation between a symptom and a medicine. So, there could be a symptom, and then symptom. could be linked with the medicine, and that could be a relation. Or there could be a relation between one medicine to another medicine based on what kind of compositions and what are the salts that are used in those medicines. So relation extraction can is a problem. So these are different problems which are conventionally they are a natural language problems. But if you are reading a medical literature or a clinical uh, literature and you want to understand and make sense out of it, then you will have to leverage these NLP uh, techniques. Medical application, document classification, question answering. So these are some of the things. So imagine, like for instance, you are studying for your in your MBBS, or you're studying to become a nurse, and then what are the books that are needed? Now, what you would in turn do, you would now in turn digitize those books, digitize that kind of knowledge which is present in those books, and you will pass them to the language models. You will make the language models read those books. And we used to get this advice when we, as human beings, when we were kids, that you read as many books as you want. Even though it's a storybook, even though it's a novel, these days people have very less of reading habit because there is mobile. But earlier we were encouraged to read as much as we can, read newspapers. So the more you read, the more new words you encounter, and you look out for their meaning. And the more new words you know, the more vocabulary size you have. And the more vocabulary you have better understanding. You can make sense of these relations. And if a question is asked, you can answer those questions. So in the same way, the language models need to be given this literature of which is medical related, let's say medical related textbooks, and then you seek an answer to these questions. Then medical diagnosis, as already I had alluded to, so they can contribute to conducting analysis on the patient's symptoms. So for instance, you can give the patient symptoms, that these are the symptoms of the patients. What is it that the language models can do? Yeah. So So yeah, I mean, I what I can do side by side, if you can see my screen, I hope you can see this tab as well. Yeah, so let's say this is Chat GPT, it is available to everyone. So you right now, for example, you want to do patient symptoms or okay, so I am having lower back problem. What should I do at home to resolve the problem? I mean, I've not tried this query before, so but let's see. So if you see it's the next word which is getting generated. So it's a generative model. In one go, you don't get everything, but it is giving you these prescriptions. As a researcher, your aim would be to come up with your own language models, if you can really do that, or otherwise, can you uh, can you support an existing or you can also use LLMs in a way where you can do prompt engineering. So there are multiple ways. So one is people do prompt engineering. Prompt engineering means this is the prompt that I have posed. If I pose a different prompt, or if I enter the same prompt again, it's not guaranteed that the model will give me the same result. So there are issues of consistency, reliability, and that is something that prompt those who are looking at using LLMs at the prompt level, which means that they are not training, but they are just using these LLMs directly in their research, or maybe solving one step in their research pipeline, right? So it is giving you these bunch of answers, right? So by conducting analysis, but it is giving you how is it able to give you this answer? It is able to give you this answer because the kind of literature or the corpus or the set of sentences that were fed to ChatGPT, there would probably be a lot of material related to medical diagnosis, right? But later on in this talk, I also will tell about some. There are LLMs in the medical which are targeted for medical related questions. So you can perform analysis on patient symptoms, medical records, and so on. So clinical decision assistance, clinical trial recruiting, clinical data administration, patient education, research support, etc. Patient care. You, by by leveraging the capabilities, you can also provide more personalized and patient-centric approach. For example, there could be a, a chat. For example, somebody and so for instance, mental health is becoming very important day by day, and therefore you can also have chat GPTs. And I mean, you typically would not people are usually hesitant to share their mental health problems to a person. And so in that situation, conversational AI and LLM driven uh, healthcare chatbots can be very useful. So they can guide the patient, and the patient it could be a dialogue, and then the patient tells his or her specific issues, and then the the chatbot can give the answer. Clinical decision support. They can provide you the recommendation, diagnosis, accuracy, treatment selection, etc. Medical literature analysis, we have already discussed this. So you can have, let's say, it can comprehensively review like what all are the treatments related to any, let's say, lifestyle disorders, like say diabetes or yeah. So and it could you can also ask the LLM for summarizing. So maybe this part is more useful for the healthcare providers, for the doctors, and they can also make use of LLMs to analyze the literature, just as we are doing. We are making use of LLMs to understand the related work in the problem that we are solving. So then basically drug discovery is 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 synthesizing different compositions and different salts, and looking at and seeing what is their impact. Can a new drug be created, and how would different compounds, when they are mixed together, how would they react? So, though this is not my area of work, but people are using LLMs to even facilitate the drug discovery aspect. But the tricky part here would be that you would need to create a corpus of all kinds of medicines, their composition, and how they are related. What are the do's and don'ts? Which two medicines usually? So sometimes there is this case that usually you don't take some medicine combinations together because not uh, they are not good when they get combined. So when you provide all these permutation combinations, or you can also provide these details of this can be substituted with this. So compositions which goes together. There are compositions which don't go together, and uh, then all that knowledge needs to be fed to the LLM, and then you ask questions. Okay, so yeah, I mean, I'm not very sure how promising this application is. What are the performance, how successful people have been, but it can be explored. Uh, Yes. Okay. So healthcare chatbots. We have already alluded to this. There could be chatbots which can offer medical advice, monitor health conditions, and even extend their services to encompass mental health support. Then comes the multimodal aspect of the LLM. So imaging. So in the medical domain, there are a lot of images that we see, images of X-rays, for instance. So you might have seen doctors looking at the X-ray and then they are making sense of what's happening. So these days you can have computer vision, vision-based models, and these vision-based models with the power of large language models, which means the generative ability. You can also use uh, these for augmenting the medical image, for example, augmenting the medical image data. And this is one of the things which is uh, is one of the open research areas, but I will talk about it towards the end of the talk as well. Then medical report synthesis, so automated medical report generation. So in the summary or in the prescriptions or in the doctor report these days, so doctors would typically write them manually, but now you can make use of the LLMs to generate automated medical report generation. It can be done through images by giving images as input, and then uh, you get a summary. It could be also based on the kind of treatment that is given. So you have to explain the treatment, what were the symptoms for which the treatment was being given, and then get the results. Right, so these were some of the applications where LLMs are poised to play some role, and there are always two schools of thought. There are people who are enthusiastic about it, and then there are people who are apprehensive about it. So we need to have a balanced view and keep evaluating how these LLMs and what they are doing. So I'm not suggesting or I'm not saying that LLM is the only answer to all the problems, but LLMs can certainly they can augment and they can help in creating a better solution. Then LLMs in the healthcare. Now, till now, we have been looking at in the background, I talked about LLMs in general. Then we looked at what are the ways in which LLMs can be applied. in medical domain. And then while we were discussing the applications, I alluded to this that you can pass a lot of medical literature as text instead of just passing what is present on the web or general material on the web. Instead of passing the general material and material related to all domains to the language models, you can pass medical specific information. And when you do that, you you basically generate LLM, which is focused on the medical domains. So, for example, Med, Palm, then there is PubMed, GPT. These are all LLMs which have started to emerge in the last couple of years, which are related to the medical part. So, for example, this is one of the very recent papers, BioMistral, and it's a popular LLM in the medical domain. So let me so I think yeah. So this is the paper which came a few months back, and so I was looking at while preparing for this talk. I was going through this paper, and they talk about a lot of things. So this is an open source LLM tailored for. So when we say open source, it means that all the parameters of the LLMs are known. You can download the entire model, and you can also fine tune the model. And then so once so it is pre-trained on PubMed Central. So this is a medical related data set, and then we conduct a comprehensive evaluation of 10 established medical question answering tasks. So once you prepare an LLM and you say that my LLM focuses on this particular domain, and then you have to benchmark it. You have to then say that, okay, my LLM is solving these 10 well-known problems in this domain. So this is what they then basically say. So, and then our results demonstrate bio Mistral superior performance, blah blah blah. And then let's look at these. So it's an so important part is it's an open source model. It's a different question that 7 billion parameters are there. So whether you would want to store it in your local systems, how it can be done would be a challenge. But but uh, so then it will talk about. So this paper will so such papers who are introducing new LLMs in the medical domain, they have to have a section on what kind of data this LLM was trained on. So they will provide you with the information on what it is trained on. So it is trained on freely accessible collection of medical research papers, PMC open access subset, right? And so one of the things, if you are say if you are researching in this domain, you can say that, okay, I can create an LLM maybe for a group of diseases or a group set of medical problems. I want to do it and not do it for the entire collection of these medical research papers. Right. So in typically in these papers, so this would be an important section to look out for, and then the evaluation part. They would be doing some amount of fine tuning. And then what are the important downstream tasks? Like, what are the 10 most important tasks? Covering these are real world. So, for example, MMLQ comprises exam questions spanning 57 subjects, including philosophy, management, and medical domain. So, we focused on the six subjects relevant to the medical and clinical knowledge. And then you see what is the response, what is the outcome response of these models. So, like, you compare it with some other medical related LLMs. So this was one good paper, a very recent paper. Then MedPalm is another paper. And so this is, so if you see the timelines, these are all last couple of years thing. A new medical LLM trained on new base model. Everybody, so all of them, so what are their common things? They will achieve state of the art results on benchmark question answer benchmarks, right? And then possibly there will also be a human evaluation, because we are always interested to know, okay, LLMs are solving or answering these questions, these medical related questions, how would a human answer them? And we compare with the human answers. So we evaluated this model, this large language models on these multiple kind of question answers. And the base LLM. So here in this section, now they will talk about how they trained, how they prepared this model. And now they're talking about uh, pairwise. So Palm was the first model to exceed a passing score in US medical licensing examination style questions with a score of this. Right. So, I mean, these kind of medical LLMs, they are again, so solving some of those problems which I said, that there are lack of doctors, lack of medical care providers, and can we bring machines to solve these problems? So this is, and then in the last part, uh, I will now be talking also about the challenges. Like, LLMs can hallucinate. Those of you who know, or if you have used LLMs, you might have encountered this problem. What is hallucination? What do you mean by hallucination? It's like cooking stories. If you and they will look very convincing. So let me just try. So I don't know how, if we can trick the LLM. Mm, uh, does drinking more water reduce back pain? Yeah, so I mean, I don't know. I mean, does drinking more water, does it reduce back pain? And now I'm lost, right? So I'm not an expert on solving this problem. I really don't know whether this answer is actually correct or not, but uh, it will say this, right? So let's does drinking more tea reduce back? Okay, so I think let's have a very bizarre ask something very drinking more. Hmm. Does taking more sugar reduce back pain? I don't know. Ah, so now it is saying that taking more sugar does not reduce pain. It can worsen it in some cases. I feel very good when I take sugar and it indeed reduced back pain for me. So, does taking sugar reduce back pain? So, my point is that if I keep putting these queries again and again, and if I keep persuading the LLM into believing that this is what I have experienced and it has worked for me, and now can you generalize? Can you say this thing? And you will see that LLM will basically they'll start speaking your language, or they will start because they don't will not argue and will not fight with you for too long. So, but this is one of the things that I experienced while I was solving some problems. But in general, there are a lot of literature on hallucination of LLMs and how they make stories. These are some examples, but there you can also have such issues. Then LLMs have biases. Okay, so I think yeah. So think I forgot to put this slide, but yeah. So LLMs are known to have biases. So for instance, some of the typical biases that uh, we know, or people who work in the domain of understanding biases, they they look at, let's say, for example, uh, gender related biases, for instance. And there are certain professions, and traditionally if you study the biases, you will find these case studies that some professions are more linked with one gender as compared to another profession. And in the context of medical LLMs, one can say that it could be that, let's say, if you are asking for a prescription, that the LLMs could be giving you one kind of prescription more often than some other kind of prescription. And because it's all probabilistic, it's all about likelihood. And if you are uh, allergic to, let's say, one kind of prescription or some medicine, it doesn't know about your allergies unless you explicitly specify that, because otherwise it will keep giving you the biased answers, the answers which are highly probable. So that is what is meant essentially by biases. So at the end of what I wanted to discuss, and just I think I should have put this caveat before. I am not working in the domain of healthcare per se, but I am using LLMs, and I find a lot of research interest in leveraging LLM to solve problems in the health domain. So this deck of slides I had prepared using mainly using one of these review paper, but there are many other review papers as well. But more or less, they are talking about similar aspects. They talk about what are the applications of LLMs, what are the different types of medical related LLMs, and then what are the open challenges or the open problems. Like this is the paper that I relied upon, but this is not the only paper. There are other papers, like for example, this is another survey paper on technology applications, trustworthiness and future directions. Trustworthiness is also an equally important aspect. So yeah, so for this, and then I was trying to look for some funny memes. So here is this person who goes and says to the doctor, "It hurts when I touch my shoulder." And the answer, the LLM can give an answer, then don't touch it. And then it charges a fee for it. So, so rather than solving the problem, you can just also answer in this way. So we would not want LLMs to have such kind of answers, right? So there are issues of trust worthiness, and therefore, yeah, so people are looking at this, right? So if I see this, so technology, we talked about background and we talked about medical LLMs, and they are using this, they are using the term medical large LLMs, right? Which makes use of the medical literature and to train themselves. And there is a whole bunch of these different LLMs, and these are the different medical LLMs and how they have evolved, uh, the training and stuff like that. Yeah. So I think I am done. If there are questions, I am happy to hear the questions. And something I should have told at the beginning. Basically, I have used LLMs to solve problems in the domain of computational social science. So, like one particular problem in which people are using LLMs is to generate synthetic data. And like for example, in this paper, we generated synthetic Instagram data, Instagram post. We generated only the text data for detecting a downstream task like sponsored content detection. So these days, there are a lot of influencers on social media, and they also uh, uh, promote a lot of stuff. And so the problem here was to tell whether it's a sponsored content or not. But in the context of medical domain as well, it's it is an upcoming problem that people are studying rare diseases, and there are diseases for which we don't have a lot of medical data, or getting medical data is very hard. So can LLMs be used to generate synthetic data? So this is one of the takeaways. You can say that is you can use LLMs to generate more synthetic data. Let's say suppose you are working on image data, medical images, and you don't have enough data, or it doesn't even matter whether you don't have enough data. You can create a research question saying that let's use multimodal LLMs to generate more medical images. And then I have a synthetic images and I have the real images. Now, can I see what is the role of synthetic images? Does it help in solving the downstream task? The downstream task could be uh, that there is a disease present in this X-ray or not. And can synthetic data help in solving the downstream task? Similarly, it could be text, could be descriptions or patient descriptions. So, for example, for some kind of diseases, patients are not very specific in mentioning what are their symptoms. And if you miss out some symptoms, it is very highly likely that the diagnosis will not work very well. So the data is less. And in all such situations, you can use LLMs to generate synthetic data and then see the effect of synthetic data on solving the problem. So that is one of the future directions. So if let me uh, I'm sorry, maybe yeah. So I mean, I should have put these things. Use LLMs to generate synthetic data, synthetic medical data, and then evaluate the the downstream task performance. And some of the these are not future I mean, you can leverage known medical LLMs, and this is basically prompt the known medical LLMs to and evaluate your proposed solution or whatever is the downstream task. So here the key idea is that you don't fine tune, you just prompt a known LLM, and you can also fine tune for a specific downstream task. Suppose you are looking at, let's say you're focusing on a mental health related issue. So for a mental health related issue, you you can fine tune the model and then so I mean these are future directions, or you can say maybe these are takeaways from this session. And there is, of course, there is a takeaway that you create a new medical LLM. But creating a new medical LLM is going to be a very big task. So create a new medical LLM but target it for specific disease family or diseases on top of existing known medical LLMs. And of course, this needs to be open source. So this even fine tuning also known if they are open source, then you can do this. Leverage LLMs to generate synthetic sorry, to generate synthetic data. So I think I'm sorry this slide was not, I had this, I thought I had put this slide, but it's not, it wasn't there. So that's it. Those are the key takeaways, and I think we still have some time for any questions. I am sorry for being late, starting the class late, and I think we have overshooted the time. Um,
Thank you so much, sir, for your kind informations, and the session was very inspiring. Sir, there are some questions in the chat box. If you check there.
Yes, I will check them.
Hello, sir. My
Yes.
question
Yes.
is that as we have discussed regarding the mental health issues and the applications of LLMs over it, but there is a challenge that LLMs shows hallucinations. So I want to ask that does it affect the application or mental health that if the LLMs are showing hallucinations?
Yeah, it is still it is a good question. It is still an open, it is going to be a still an open problem. It is a challenge. It's not a solved problem. So in medical health, like I said, so health, the LLMs are prone to persuasions. If you keep persuading them, uh, I mean, like, let's say very simple thing. Like, so I'm not able to prepare for my exams. I've been procrastinating. I've been like just wasting my time in screen time. You are asking, you put all these things, and then you get an advice. But if you keep persuading that no, I don't want to have your advice. So I mean, LLMs could be a little tricky there, but yes, hallucination is going to be a big problem, and it needs to be addressed. And I'm sure, I mean, I don't know of literature, research literature, as I mean, unfortunately, I don't work in this particular domain. So, but it will be a big. You have to take that into consideration if you are looking to solve LLM using LLM, you want to solve a medical health related problem. Then there is a question. There is a question for research. Can we implement LLM in healthcare? What are its requirements and tools available to go ahead with rare diseases? Yes, you can do that. And so again, the in terms of the tools, you will have to create a model. So you should know how you do model training, or let's say a simple language model. How do you train a simple language model? How do you supply the inputs? How are those input sentences, they are tokenized? What kind of tokenization? What is the embedding layer? What is the architecture of the model? Is it the transformer based model? So these are the kind of background. So you would need a course on machine learning definitely if you want to uh, create and propose your own LLM from scratch. And with respect to rare diseases, you need to know some material about them, about the diseases, and what are the benchmark question and answers related to those diseases for evaluating whatever you come up with. So, I mean, I would strongly say that these future directions or takeaways, focus on these takeaways. If in one slide I have to summarize this entire talk, I would say it is going to be this slide. And I hope I have answered that.
Sorry to interrupt, sir, but
Yeah.
it's the time to conclude.
Yeah. Okay.
Uh,
And yes, you can also
okay,
use
so
federated
One
learning
question.
to do the, yes,
Hope I'm audible.
yes.
uh,
Sir,
okay, thank
so
you so much,
this
sir.
Okay, thank you. I
Yeah,
think
Akshat,
there,
please
okay,
I
go
have
my
a
ahead.
question.
quick question.
Yeah, Akshat has a
Uh,
question. Yeah, maybe
yeah,
I'll have one last question we take and then we wind up. Yeah.
sure. So, can the synthetic data generation of synthetic data be a solution for passing demographic data to LLMs? Like, can we, since the demographic data can't be directly pushed to LLM, so can synthetic data could be an
Yeah. A good
alternative there?
question. So yes, yeah, private data. So
Right,
in case
compliant.
of private data, yeah, I mean you have to generate synthetic data, but then the generated data should not be linked to any individual. Or the synthetic data that you generate should not get linked to any person or any other attribute which are personally identifiable attribute. So we are dealing with only symptoms right now and patient IDs in anonymized form.
Yes, sir.
We are not going to look into the personalized data.
For use cases like report generation or personalized guidance or personalized support, if like for example, getting the
Yeah,
guidance
you
on
can give,
neck
yes, you
pain.
can give personalized, yes, you can give personalized support, but without knowing the name of the person and the identifiable attributes,
So
like
synthetic data could
without
be
knowing their email ID and so these are personal attributes. So, but yeah, symptoms can be very personal, but from the personal symptoms, you cannot link it to the actual person, right? So that is fine, but no personalized attributes.
okay. So yeah, like synthetic data could be an alternative for demographic data.
Yeah, it can be. It for different demographies.
So can you comment more on that part?
Akshat,
How?
Akshat, a
Yeah,
humble request. Can you please send an email to Dr. Rishabh? We'll share the email ID and then
yeah.
you can talk since we are already
Yes.
running late and we had to wind up this session at 9 and it's 9:23. So
Sure.
thank you so much, Dr. Rishabh, for
Yes.
accepting our invitation and giving a talk to us. I hope all the participants were benefited the knowledge related to the LLMs and the related questions that Dr. Rishabh has pointed out. So thank you so much. Thank you to all the participants and thank you so much to Dr. Rishabh. The feedback
Thank
is
you.
open. You
Thank
can
you.
please fill in. The participants are requested to fill in the feedback. Okay. Thank you so much, Dr. Rishabh. Bye.
Thank you, ma'am. Thank you.
Okay,
Thank
bye.
you,